Hey guys, today I'll be doing problem 32 from section 3.5, and this is a combinations problem that deals with probabilities and expected values. The problem starts with a lottery game where we have this lottery ticket that chooses 10 numbers out of 80 possible numbers, and we also choose 10 numbers out of 80 possible numbers. And the way to win is if we match 10, 9, 8, 7, 6, or even 0 of the numbers on the lottery ticket. So if we match any number of those on the lottery ticket, then we win and we make some profit. If we match 1, 2, 3, 4, or 5 numbers, we do not win, and we lose our dollar that we paid the ticket for. So part A asks us to find the probability of the first prize, second prize, and third prize, where these correspond with 10, 9, 8 matching numbers respectively. So as this is a combinations problem, we're going to be using n choose r, and as a refresher, n choose r, the formula for this is going to be n factorial divided by r factorial times n minus r factorial. So to find the probability of the first prize, we're going to start with 10 winning numbers, and we're choosing how many are we choosing to match those 10 on the lottery ticket. Well, we're choosing 10 of those, and we're going to multiply by 70 losing numbers because there's 80 total numbers, and we're choosing how many of those to not match or to lose. Well, we want 0 because we want 10 winning numbers, and we only have 10 numbers to pick from, right? Or sorry, not 10 numbers to pick from, we have 10 numbers that we are picking. We're going to divide this by, what are we dividing by? We want the total number of combinations that the lottery ticket can have. So this is going to be the total, and we're going to use this formula to find it. Let's start with 80 numbers total divided by, well, the lottery ticket is going to choose 10 of these 80 numbers. So we're choosing 10, and 80 minus 10, and this formula right here is going to be 70 factorial. If we multiply this out, it's going to be 1.646 times 10 to the 12th, which is a very large number. So I'm going to keep it in this scientific notation just for ease and uniformity. So let's move this right here. And if we multiply this top part out, this is going to be 1, and this is going to be 1. So this is just going to be 1. Let's replace this with 1. And if we think about this intuitively, if there's 10 numbers on the lottery ticket, and we want the number of ways to match all 10 of these numbers, well, there's only one way to do that, and it's to match all 10 numbers, right? So intuitively, this makes sense why the numerator is going to be one possibility. Now, the second part of part A is going to be the second prize, which is 9 matching. We're going to use the same procedure as before, where we start with 10 winning numbers, we're choosing 9 of those, we're going to multiply by 70 losing numbers, and we're choosing how many do we want to lose. Well, if we have 9 matching, then we must have 1 non-matching. We're going to divide this by our total, which was 1.646 times 10 to the 12th. And if we multiply out the top numerator part, this is going to come out to be 700. And the reason I am not multiplying the bottom part out and then simplifying this fraction is because this is a very large number, so we would get a super small probability, and it's just a pain to write all those numbers out. Plus, it'll be more uniform this way. So let's do the third prize, which is 8 matching numbers. The same procedure. 10 winning numbers, choosing 8 of those to match, times 70 losing numbers, choosing 2 of those now. And if we multiply this top part out, we will get 108,675. Good, so those were all the probabilities for part A. First prize, second prize, and third prize. Now moving on to part B, we want the probability of losing. And the probability of losing, we can use the complement rule, where the complement rule says if we want the probability of losing, then we can do, since we're in percentages, we want the total max percentage was going to be 1, and we're going to minus the probability of winning. Right, so the probability of winning, the total probability of winning, let's think about how many ways can we win. Well, if we win if we match 10 numbers, 9, 8, 7, 6, or 0 numbers. So 10, 9, 8, 7, 6, or 0, right? But we already found 10, 9, and 8 matching numbers because we did that in part A. So all we need to do is find 7, 6, and 0 now. And then we do 1 minus the sum of all of these probabilities, and we'll have the probability of losing. So let's do that, and we're going to do the same procedure as before, where we start with 10 winning numbers. We're choosing 7 now. We're going to multiply by 70 losing numbers, and we're choosing 3 to make 10 numbers that we have, and divide this by 1.646 times 10 to the 12th, and multiplying the top part out, we're going to get 6,568,800. Good. Now for for 6 matching numbers, same procedure. 10 choose 6 times 70 choose 4. Multiply this out, put it into your calculator. You will get 192,547,950. And you can see that with less matching numbers, we're going to get larger and larger percentages, which makes sense because there's more and more ways to make those combinations because it's less restrictive. So now all we need to do is find 0 matching numbers. So we're going to start with 10 winning numbers. We're actually going to choose 0 winning numbers, right? Which makes sense because we want 0 matching. So 70 losing, I want to choose all of our numbers to be losing now. Now multiply this out, put it into your calculator. You will get 969 times 10 to the 11th. And since these are both large numbers, you could actually divide this and get a reasonable number, but I'm going to keep it as is just for sake of uniformity. Now that we have all of our probabilities for winning, let's add all those up, and we'll do 1 minus that probability, total probability, and we'll have our probability for losing, right? Because we wanted probability to lose equals 1 minus probability of win. Now, so the probability of winning is going to be 1 over, I'm going to keep this as, actually, 1 over the total. So we'll factor out the total, 1 over total. We know the total is going to be 1.646 times 10 to the 12th, but it'll just be easier to write it like this. I'm going to multiply it by 1, so all of the numerators of the probability of winnings, right? So all of our winnings. 1, so we had 700 plus 108,675 plus, what did we have? We have 6,568,800 plus 192,547,950 plus 3.969 times 10 to the 11th. And we're going to do that just to keep things clear. Now again, all of our probabilities were these numbers divided by the total, which is 1.646 times 10 to the 12th. Because they're all divided by that, we can just pull it out in the front, which is what I did here. Now if you add all these up, divide by this, 1 minus this entirety, we'll finally get, putting this into your calculator, finally we're going to get 3.969 times, did I mess up? Ah, yes, I did. Sorry, this is supposed to be a 7. And before, when we calculated the probability to match 0 numbers, it was also supposed to be a 7, so just change it to a 7. And this is going to be 3.969 times 10 to the 11th. Divide this by our total, which is 1.646 times 10 to the 12th. And now, if we do this into our calculator, we're going to do 1 minus this. We're going to get 0.7589 roughly. So this is a long procedure, but we found the answer to part B. Probability of losing is 0.7589 roughly. Now, moving to part C, the expected value. Let me just clean this up real quick. Okay, so the expected value, and I made a little side note at the bottom here. What is the expected value? So expected value is the sum of probability times value of all the outcomes. So it's going to be, here are the outcomes, our matching. Here are our values, the profit, and we know the probabilities. So we are simply going to do, let's do probability first. So 1 over total times what is our value? Times value of outcomes. So what is our value for 10? 10 matching. It is 499,999 plus 9 is going to be 700 over our total times 5,999. And we're going to keep going. This is the probability for 8 matching. And our value for 8 matching is 299 plus 7 matching was 6,568,800 over the total. What is the value for 7 matching? It was 39. Now we're going to do 6 matching, which was 192,547,950 over the total. And the value for that is $9 that we profit, plus 0 matching now. We had that as 3.967, not 969, sorry about that earlier, times 10 to the 11th over 1.64. I'll just keep this as total as well. Right, now we want losing. So the outcome of losing, well, we found that in part B. So the probability of losing was 0.7589, and the value for losing is going to be -1. Right, so now what we want to do is just put this all into your calculator, sum it all up. For that, we're going to get a grand total of -0.03567. Now, in cents, this would be negative 0.03, maybe 6, we'll cut off there. So roughly 4 cents, -4 cents, is our expected value. So what does this mean? It means that for every ticket that we buy, we expect to lose roughly 4 cents, 3 to 4 cents. That's our expected value, and this is our answer, right? Alright, that concludes the problem.